Welcome and thank you for watching this NBC Montana special, School of Weather Wonders, Unraveling Nature's Secrets. I'm Laurel Staples. The NBC Montana Severe Weather Alert Team is always working for you. Meteorologist Mitchel Coombs takes us on an educational journey using 3D weather technology. First, ever wonder about the fresh smell of rain? We did a little digging and found there's more to the scent than just the rain itself.
If we made a list of the world's best smells, aromas like freshly baked cookies and spring flowers would probably be there. There's a good chance the sweet, earthy smell of rain after a spring or summer shower would also be near the top of the list. Personally, this smell brings back a plethora of childhood memories. The scent is unique and is known as petrichor. However, I have to first start by bursting the rain bubble. Rain is simply water and it doesn't produce a smell of its own. However, it is very important in the process. For this pleasant smell to reach our nose, it all comes down to biology, chemistry, and a little bit of good timing. Regarding timing, the strongest scents occur following a period of dry weather. During these periods, plants secrete oils which accumulate in porous soil and rocks around the plants. As rain falls, the oils combine with rain and other compounds in the soil. As these compounds begin to break down, they release the scent that we've become fond of. One of these compounds that is particularly sensitive to our nose is a soil-dwelling bacteria known as a geosmin. These bacteria get caught in the water droplets as they hit the surface, but as the droplets bounce back up into the air, they break apart and release these bacteria as aerosols into the environment. Ahead of thunderstorms, an even more pungent smell can develop as compared to the typical shower. This smell is lightning-driven. Lightning splits atmospheric nitrogen and oxygen atoms into separate particles, some of which combine to produce ozone. Ozone is the cause of that stronger smell and is always present in the atmosphere. A thunderstorm's downdraft pushes the ozone to the surface, allowing us to smell the rain coming. The next time it rains, take a moment to appreciate the wonderful, earthy smell of petrichor it helps create. For your current conditions, as well as interactive radar, download the NBC Montana weather app. Reporting in Missoula, Mitchel Coombs, NBC Montana.
Fresh snow on the ground can produce beautiful sights, but did you know that snow can also affect sounds? Let's find out why snow is considered nature's earplugs.
Have you ever stepped outside while light snow was falling, or went out to shovel the driveway shortly after snow had fallen? You may have noticed that it was quieter outside than normal. There is a scientific reason for that, and it involves the snowflakes themselves. Let me explain how snow got the nicknames nature's earplugs and nature's headphones. The most common type of snowflake is known as a dendrite. This photo from Paula Buchanan shows great examples of what dendritic snowflakes look like. They each have 6 arms and oftentimes have plenty of nooks and crannies. These gaps are very efficient at catching sound as the snow is falling. So as the sound is passing through these snowflakes, it creates a dampening effect before that sound reaches our ears. It doesn't matter if the sound comes from a car, a snowblower, or even the animals out in nature, the dampening effect will be just the same. The quieting effect will continue even after the snow ends as long as you remain in a fresh snowpack. The piled up dendrites will continue to catch sound even on the ground. The lighter and fluffier the snow, the greater the sound dampening effects will be. However, the same cannot be said for a dirty, old snowpack. As the snowflakes melt, they begin to lose their dendritic structure and the arms start to close off. This diminishes the amount of sound that can be captured, lowering the dampening effects. Eventually, all sound levels will go back to normal. If you're looking for some peace and quiet and don't mind the cold, the next time it snows, head outdoors and go and enjoy the sound dampening effects of snow in action. Reporting in Rattlesnake Canyon, Mitchel Coombs, NBC Montana.
Sticking with the cold, an uncommon sight spotted by a viewer near the shore of Flathead Lake, dozens of ice discs on the water's surface. But how do they form?
You may never have seen pancake ice before, so try to imagine it with me. A large cold body of water, be it the ocean or a large lake, covered in dozens of frozen circular discs with raised edges.
They may look more like lily pads or even a deep dish pizza to you. So to give you a visualization of what these look like, take a look at this photo sent in by Brent Dory of Pancake Ice on Flathead Lake near the Big Fork area. They certainly are a unique sight, but how do these formations get their shape? Pancake ice formation is dependent on very specific conditions. Temperatures must be just below freezing from about 26 to 32 degrees in areas with very little to no wave action. While you can see semblances of pancake ice in rivers, the increased motion of the river generally prevents it from forming. This is why larger lakes such as Georgetown and Flathead Lake are perfect examples of locations to see them. To continue the explanation of pancake ice development, let's shift into an aerial view. Pancake ice begins as a thin layer of slush and ice on the water surface that then freezes solid. You now have a large sheet of ice that is slowly broken up by small waves and other water movements such as currents just below the water's surface. Now this will generally crack that ice into large geometric shapes, and for this example we're going to look at those as squares. Over time, these larger ice chunks rub up against one another, creating those raised-edged circular discs that make the pancake ice. Pancake ice is fleeting. Surface winds in combination with a lake circulation can help to move these formations out very quickly. Additionally, lake and air temperatures will determine how long they last. If you happen to see pancake ice, count yourself lucky and don't forget to take a picture. If you feel inclined, share those photos with us at NBCMontana.com/chime-in. Reporting from the Clark Fork River in Missoula, Mitchel Coombs, NBC Montana.
The sky can produce some amazing sights. One feature considered to be more uncommon is known as the Sundog.
The sky can produce some incredible sights, and one of those features is an optical phenomenon known as a sundog or parhelion. Sundogs generally consist of one or two bright spots that flank the sun on each side along a 22-degree halo. Sundogs develop in a similar fashion to other optical phenomena such as rainbows. However, there are some key differences between rainbows and sundogs. For example, the light passes through water droplets and splits into the colors to develop a rainbow. Now, sundogs, on the other hand, these form when sunlight passes through hexagonal ice crystals from cirrus or cirrostratus clouds. As this light is passing through the crystals, they refract back together, and the point where they connect results in a sundog. Sundogs display in a variety of ways. Sometimes they're colorful lights with a reddish hue. Other times they're so bright and intense that it looks like there's another sun or two in the sky. This is where they get the additional nickname mock sun. Despite the beauty that sundogs can provide, they can be precursors to rain and snow and indicate an approaching storm system. This photo sent in to us by Kate Price through Chime-In shows a pair of sundogs flanking the sun along a faint 22-degree sun halo. Sundogs are capable of being seen at any time of the year, but the best time to see them is when the sun is low on the horizon, be it in the evening or when it is low in general, such as the month of January. If you have photos of unique optical phenomenon such as the sundog, send them to us at NBCMontana.com/chime-in. Also, if you have any weather or science-related questions you would like answered, email those to me at mrcoombs@sbgtv.com or reach out to me on social media. On Twitter, you can reach me at MitchelNBCMT or on Facebook at Meteorologist Mitchel Coombs. Reporting from Blue Mountain in Missoula, Mitchel Coombs, NBC Montana.
A reminder to download our NBC Montana weather app for immediate storm alerts and warnings. It's always free in your Apple or Android app store. Our weather team regularly updates information to keep you informed and empowered 24/7. Coming up, how did the elements of weather affect the travel and flight of a football, say a kick or a long pass? We'll show you how science plays a key role in the sport. Plus, it's one of the most beautiful moments to witness in the Treasure State, the aurora. Mitchell explains how the atmosphere shows off the brilliant display of colors. Welcome back. Weather can affect sports in many ways. Meteorologist Mitchel Coombs took to the gridiron to show us the weather's impacts on football with the help of 3D technology.
Football season is here, and what would fall be without it? Whether it's high school, college, or professional, teams across the country are taking to the gridiron to show their skill and ability. However, when they take to the field, it isn't just the other team they'll be competing against. Sometimes it's also the weather. There are 3 weather-related factors that may influence the outcome of a game: temperature, precipitation, and wind. First, temperature. All footballs will deflate as the temperatures cool, so if the temperature drops 10 degrees throughout a game, the air pressure inside the ball will drop by about 1 pound per square inch. This might not sound like much, but with the quickly dropping evening temperatures, a football may lose up to 20% of its air by the end of the game, making it less bouncy. This could spell trouble for a kicker because kicks later in the game will come off the kicker's foot at a slower speed. Also, cold air is more dense than warm air. This results in more drag on the ball as it flies, decreasing the travel distance as well. For example, a 30-degree temperature change with no wind will result in a difference of about 5 yards of distance. Falling rain and snow will make the football slippery, negatively impacting the quarterback's ability to throw the ball and the rest of the offense's ability to catch the ball or maintain possession. This is due to a decrease in friction between the ball and the player's hands. Regardless of the defensive or offensive standpoint, it can be tough to make crucial plays if players are losing traction slipping on a wet or icy field. High wind can really mess with the trajectory of a football's flight. For quarterbacks, this can result in a pass that is well short of the intended target, as well as those that sail beyond them. This leads to a clear trend. As wind speeds increase, all passing stats, be it passing yards, yards per attempt, passer rating, or completion percentage, decreases. The place kicker has an increasingly difficult task as the wind speed increases and the wind direction changes. Wind directed from behind the kicker can assist the ball in flight, giving it a greater travel distance. The opposite is true if the wind is directly in the kicker's face. Crosswinds are even more difficult to deal with as it will force the kicker to compensate for the kick's direction for the wind. The longer the kick is, the greater the adjustments needed to successfully make the kick. Share these facts about how weather impacts football with your friends and family and score some big points at the next tailgate. Make sure not to fumble on your pregame preparations for not knowing what type of weather you might face come game time. So download the NBC Montana weather app and score a touchdown for being in the know. Reporting in Missoula, Mitchel, Coombs, NBC Montana.
When we think of raindrops, the classic image of a teardrop may come to mind. Is this shape true for raindrops, or is it a weather myth?
We all know raindrops falling from the sky have the classic teardrop shape. However, this isn't entirely true. Turns out this is a long-held weather myth. So let's debunk the myth and dive into the science behind what raindrops actually look like and how they get their shapes. The shape of the raindrop is determined by 3 factors: the surface tension of the raindrop, the airflow or pressure on the underside of the raindrop as it falls, and the size of the raindrop, often determined by the amount of collisions with other raindrops within the cloud. While the classic teardrop shape does occur, it only happens when water is dripping slowly, similar to as it drips out of a faucet. The forces acting on a raindrop when it's falling from the clouds thousands of feet in the air are quite different. Smaller raindrops, less than 1 millimeter in diameter, are often perfect spheres because the surface tension of the raindrop wins out over the pressure from below. As the raindrop increases in size, its fall velocity increases as well. This results in an increase in pressure from below, which starts to transition the shape from a sphere to more of an elongated oval, similar to a hamburger bun. The largest raindrops are the most unique. At around 4.5 millimeters and larger, the pressure on the underside of the raindrop becomes so great that it distorts the shape of the raindrop to something more similar to a horseshoe or parachute. These parachute-like raindrops can even lose their surface tension, separating that raindrop into 2 separate smaller raindrops, beginning the cycle again. In general, the larger the raindrop, the greater the pressure acting on it from below, and this decreases the surface tension of the raindrop itself. Now you know the next time it rains that raindrops aren't that classic teardrop shape. Reporting from Blue Mountain in Missoula, Mitchel Coombs, NBC Montana.
To watch all of Mitchel's weather stories or weather coverage, go to our website, nbcmontana.com. Still ahead, talk about a Montana moment. A splendid display of the northern lights fills the night sky. Using 3D weather technology, learn why the aurora borealis is so magical. Do you have an Echo device? If so, you can get severe weather alert updates and the latest news on your Amazon devices. Just say, "Alexa, what's my flash briefing?" But first, here's what you need to do. Download the Alexa app, go to Settings, select Flash Briefing, and search for NBC Montana. The aurora borealis is one of those spectacular sights that can fill the big sky of western Montana. It's really a Montana moment. But how does this phenomenon form in the atmosphere?
Now, in recent months, you've likely heard us talking more about the potential of auroras. This has a direct link to the increased activity of the sun.
Storms on the sun cause events such as coronal mass ejections, or CMEs, and solar wind from coronal holes to send charged particles hurtling through space. If the Earth is in the path of this charged particle stream of protons and neutrons, our planet's magnetic field and atmosphere will react from the impact. Particle collisions excite the molecules which produce the wispy, elusive lights that fill the night sky with color similar to how neon signs give off light. The aurora's colors are dependent on the height and type of atmospheric molecules the solar particles collide with. Nitrogen collisions produce pink auroras below 100 kilometers and blues between 100 and 200 kilometers. When oxygen is involved, green auroras show between 100 and 200 kilometers, with red auroras above 200 kilometers. As billions of flashes occur in sequence, the auroras appear to move or dance in the sky.
These lights are commonly found around the poles. However, stronger solar storms can bring those lights southward. When we get to geomagnetic activity level of KP5 or higher, that's when western Montana will see its best chance of seeing the aurora borealis. If you have any photos or videos of the northern lights that you would like to share, send those to us at nbcmontana.com/chime-in. Reporting from Waterworks Hill in Missoula, Mitchel Coombs, NBC Montana.
We couldn't show you all of Mitchel's stories, but you can watch them online, nbcmontana.com. Also, be sure to follow us on all of our social media platforms. Our NBC Montana special, School of Weather Wonders, Unraveling Nature's Secrets, continues after the break. Next, how is lightning created? That story in 2 minutes. Now you can stay connected to important news you need all day long, summarized and delivered right to your inbox. Sign up for the NBC Montana newsletter. Top local stories and weather from the team that's working for you. Easy to find, all in one place. Sign up for the NBC Montana newsletter and stay connected. As thunderstorms develop, they can produce lightning. But how is lightning created?
Lightning is one of the greatest concerns regarding thunderstorms. Forecasting where and when lightning will strike is not yet possible, but by learning about lightning and following a few safety tips, you and your family can avoid the danger of one of the most unpredictable forces of nature.
For lightning to be created, we first need to develop a thunderstorm. Thunderstorms have very turbulent environments with strong updrafts and downdrafts located within close proximity to one another. This causes water droplets and ice crystals to move past each other within the cloud. As this does so, a critical effect occurs. Negatively charged electrons in the ascending particles are sheared off and collect in the descending direction. This results in a thunderstorm cloud with a negatively charged base and a positively charged top. A second area of positive charge develops closer to the ground on taller surfaces such as trees, buildings, and even us. In the world of electricity, opposites attract and insulators inhibit. The atmosphere is a very good insulator, so a tremendous amount of charge must build up before lightning can occur. A stroke of lightning begins as a channel of negative charge known as a stepped leader that descends towards the surface from the base of the cloud. At the same time, positive charge will reach up towards that negative charge in what is known as a streamer.
When these channels connect, the resulting electrical transfer is what we see as lightning. All of this occurs extremely quickly, in less time than it takes to blink our eyes.
After the initial lightning stroke, if enough charge is left over, additional strokes will pass through the same channel and give the bolt its flickering appearance. The most common types of lightning strikes are cloud to ground, intracloud, and cloud to cloud.
As for the dangers of lightning, we need to pay close attention to the weather as we enter the summer months and outdoor recreation increases, because the lightning-related fatalities increase in this period as well. The best advice to take regarding lightning is when thunder roars, go indoors, preferably to a sturdy structure. If you have any weather or science-related questions you would like answered, email those to me at mrcoombs@sbgtv.com or reach out to me on social media. On Twitter, you can reach me at MitchellNBCMT or on Facebook at Meteorologist Mitchel Coombs.
Reporting in Missoula, Mitchel Coombs, NBC Montana. I want to thank you, our viewers, for relying and trusting on us for your weather needs and coverage. I also want to thank the NBC Montana news team for making this all possible. I hope you have enjoyed learning about the wild and wonderful weather of Montana as much as I have enjoyed reporting it. As always, if you have any weather or science-related questions you would like answered, email me at mrcoombs@sbgtv.com or reach out to me on social media. Until next time, keep an eye to the sky. You never know what weather wonder you might see.
We ask you all the time to submit your photos and videos. It's simple and easy to do. Here's how.
Go to the NBC Montana app and select Explore. Then select the Chime In option. Scroll down to Submit Content. Add your pictures or video by pressing Upload. Enter a comment, then select your category. It can be weather, pets, Montana moment, and much more. Enter your name and an email address, then select Agree.
So stay with NBC Montana to see your photos on air and online. And I'll be working for you, bringing you the latest weather forecast.
Depend on Chief Meteorologist Brooke Foster. Weekday mornings on NBC Montana Today.
We hope you enjoyed watching School of Weather Wonders Unraveling Nature's Secrets. The NBC Montana news team is always working for you. We leave you, though, with some beautiful weather shots of the Treasure State from the NBC Montana Sky Team. Thank you for watching.